Hello student, today I'm going to talk about visual acuity, the module number 12. So we have finished recently physiology of vision, then visual pathway, and now I'm going to talk about the vision. And vision is measured by which? That is visual acuity. Let's see. Visual acuity basically is a sense, contains light, form, contrast, and colors. This thing we have read during our physiology of vision already, and that added together we can call it visual acuity. So vision or visual perception is a complex integration of sense, contains light sense, form sense, contrast, color sense, all the sense, collectively known as visual acuity. Visual acuity is a measurement of the spatial resolution of the eye, or in the other word we can say an estimation of the its ability or to discriminate 2 points. So basically, it's a capacity of eye to discriminate between 2 points. That's basically called visual acuity. Now coming to the theories of visual acuity. So the first one is the receptor theory. If the image fall on the two cones separated by an illuminated cone, then the 2 point light would be perceived as a two distinct sources. Understood? So what is that telling in the receptor theory? Receptor, we know that rods and cones is the receptor. So when two cones are separated by one illuminated cone in between, let's say two cones A or B you have seen, in between there is an illuminated stone is placed over there called O. So A and B you can see is a two distinct sources. So in terms of length of the retinal image, 2 points will be seen clearly when there is image size is more than 4.5 micron. So the two distinct pointers that you can see only when it's going to be, the size should be more than 4.5 micron in the retina. Then you can see, otherwise you cannot see this. In terms of visual angle, now coming to another part. First they say, okay, how are you going to discriminate? First they say that when they have something in between, then you can discriminate. Difficult otherwise. Okay. So first is something should be there in between to discriminate the two things. Second, they say, okay, you can see the 2 points when the size is more than 4.5 micron. Otherwise, you cannot see. Third one, what they're telling, there should be some angle, visual angle that is called. So that angle is subtended in the nodal point of the eye. So here, actually, you can see here, the subtended the nodal point of the eye. This is the center point of the lens, basically, where they form the through the principal axis or visual axis. This is called visual axis. So the object form an angle or subtend angle in the nodal point. So that is called visual angle. This is whole is a visual angle. This one. So it's A N B. That's called A N B. So the visual angle is the angle subtended at the nodal point by eye object in the visual field. So this is the angle. Okay, angle is the called A N B. Is the angle. So this is the called visual angle, which is the most important thing, and this should be more than 1 minute apart. Otherwise, it won't form any image. So it should be more than 1 minute apart. So this is the receptor theory. So here is shown over here is the nice diagram. The tree is the flower, which is again a nodal point at angle. The visual angle this is, and there is a form image over there. And it's an inverted image. How is going to be inverted? We're going to talk later. So this is that another diagonal representation. Another also important, the dimension of the visual angle depends on the size of the object and the distance of the from the eye. And two important objects. So two things are important. As the one is the distance from the eye, the object, and size of the object. Both are matter for the angle subtend. So distance and as well as the size. So visual angle is proportion to object and distance. Size of the distance. Relay criteria. The 2 points of sources are resolved from each other when it's separated at least the radius of the array disk. Until unless there is a array disk formations over there in that they cannot be resolved as two objects. So here see this is not resolvable. So here the array disk, so you can see 2 points are there. Here again the really limit, because this much if it is there they can be resolved. Here also you can resolve, but it's again difficult. But here is see two distinct. Here you can see two distinct, but again is a mingle together. Here you cannot. So this is not resolved. Usage of the visual acuity, where you use the visual acuity, visual functions to detect the visual functions first. Refractive status, is that in power or not? We check the visual acuity first. Outcome measurement for the treatment. Okay, any treatment, any surgery, any other disease conditions. After that, we check the vision only, because that's the most important part. Medical legal purposes for any legal aspects, visual acuity is very important. Criteria for person's fitness to drive, driving license, this is also very important. Eligibility for entrance tests, some professions like pilot, navy, and army, and so on. So many professions are there where vision is most important. Component of the visual acuity, there are 4 components are there. First, minimum visible. Second is resolution. Third one, recognition. Fourth is minimum discriminable. Minimum visible is ability to detect whether the object is present or not in the visual. So something is there in front of you or not, that is called minimum visible. So minimum visibility. You can see something in the, it is too far. You can see something is there, but you cannot recognize what is that actually. So that is called minimum visibility. Second is resolution. Clinically measures the visual acuity, discrimination two spatially separated types. So this is only the measurement of visual acuity, where we can discriminate or separatize two targets, means A, B, C, D, whatever is there, we can at least identify. The recognition. Recognition is what? Yeah, recognition. Discrimination, the visual characteristic, and identify the pattern in the memory. Identification of faces. That is called recognition. Recognition, you know the recognition? Recognize করা কিছু কাউকে? To recognize something is called recognition. So something is there over there to identify or recognize it. Is it A or B or C or D, whatever, or faces. So that is called recognition. Fourth is minimum discriminable. Spatial distinction by an observer when threshold lower than the ordinary activity. So something is present over there, but it's not that level up to the threshold to the for recognition or resolutions, lower than that. But till you can discriminate two things over there. Let's say chair and table or duster and chalk. You can discriminate two. So that's called minimum discrimination. First coming to, let me explain over there. First is that minimum visible. The spatial threshold level depends upon the specification of the stimulus, size, shape, and illumination. Definitely, that's very important. Something is there or not. You can identify until unless it's Size, shape, and illumination is there. Something size. There's a teeny particle and it's just keep it in a 10-kilometer distance. Can you see? No. And there's no light also. So you cannot see. So these three things are definitely matters. A black dot, for example, a black dot against a white background detected it is diameter of the order to 30 seconds apart or more. So when you can see any odd or anything in the white background, so that should be more than 30 seconds apart, the form angle. Otherwise, they're going to see a black square against a white background in a length of diagonal of 30 seconds. So minimum that visible is that, although we say just now that angles are tended 1 minute apart and then 5 minutes apart, you can see any later. But here, you can say minimum visible, at least 30 seconds. Visualization of a thin telegraphic wire against a uniform sky, thickness of half second apart, and conversion sub-threshold signal from a number of individual retinal elements and yields the supra-threshold level of activity. Sometimes what happens, they say that the telegraph wire very thin and they said definitely in the background is blue sky, so very difficult to recognize sometimes. So that threshold is 1/2 seconds apart. So that is very low and there is supra threshold to see that it. So detection of an illuminated object against a dark background depends on the insetting on the side. So again another issue. So anything is illuminated, you can see easily. So there's a size doesn't matter. A small teeny particle, but it's illuminated, it's light. So you can see easily. That is resolution. Ordinary visual discrimination to specially separated targets like A or B or two lines or two dots. You can segregate or you can identify. Minimum separation between 2 points, which can be discriminated by minimum resolvable. So the terminology says when you can discriminate, that is the minimum resolvable. Measurement of the threshold of the discrimination is an assessment of function of Fourier center. This is purely depend on the Fourier center, the central part of the macula and the retina. That is the Fourier center. Last time we read. So that's the pure part. Normal angular threshold discrimination for resolution 30 to 60 seconds apart. Minimum angle of resolution, that is called minimum. So to see total resolution or to discriminate something, minimum angle is 30 to 60. Remember this one for short questions. So to identify this is or this is or this is this is something which is you need a 30 to 60 seconds apart to see an object. Minimum discriminable or hyperaccurate. That is sometimes termed as hyperaccurate. What is that? Ability to discriminate whether the or not two parallel or straight lines are aligned in the frontal plane. That's called vernier accuracy. This is line straight, parallel or not any. See, there's a discrimination over here. See this line and see this line. So this, to identify it, this is something which is you need a threshold of vernier accuracy to 10 seconds apart. Very low threshold. You can to see this is to discriminate. It is called hyperaccuracy sometimes or vernier accuracy. Factors affecting the visual acuity. What are the factors affecting the stimulated relative? Luminance, definitely illumination there or not in the object. Geometric configuration of the stimulus. What are the shape size? Obviously. Contrast, obviously with the factor. Wavelength of the stimulus light, yes, so which light wavelength because all have a different wavelength. Exposure of duration, how many the duration basically. So the more duration, it is easy to understand more. You can see. So interactions affected with targets. So that is the stimulus related, observer related. Retinal locus stimulations. Okay, so that's important. The anatomical figure, pupil sizes, accommodations, affected eye movement, meridional variation in the acuity, optical element of the eye, developmental aspect. So many things are there important. This is more important rather than this part. because this is something which is related to eye object, your eye anatomy. Your eyes is okay or not, that is the most important. Then you can see the object. So first retinal the function properly or not. Then pupil size, the 3 to 6, we have 2 to 3 millimeter or maximum 3 to 4 meter. The size is also important. If it's too low or too high, then it's a big. Too big, then it's a problem. Accommodation, accommodation also is important because that just helps to see the near object. And far they don't have any role, but near object, yes, again is a role. Effect of the eye movement, yes, to move your eye from distance to near or any point of to see an object, definitely remove your eye. No, so eye movement also is an important factor. Mental variation is that your power, that is basically power related problems. So when you have one meridian, you have two principal meridian, horizontal and vertical. So two principal meridian have different power actually. So is there a power is okay, then you can see, otherwise it's difficult. Optical element of the eye, is there any problem in the eye because you need power or not? That is also, and developmental aspects. So the developmental aspect of the whole the anatomical structure of the eye is okay or not, that is also important. So how we measure the visual acuity? You know that one. All of you this one already. You have done so many times this practical already in our practical lab, and also we have attended Y camps in the schools, in school screening camp. So we have done this one very clearly. How you record the visual acuity monocularly, definitely from the starting from the right eye to the left eye. Then you record the near visual acuity. We have done it. So we all know about this one. Visual acuity test, we have so many types of tests as there. So that is something which is like detection test, then recognition test, then resolution test. Under the detection test, we have dot visual test, cat4 test, drum test, then proc candy, bread test, then steady card, striker, graded wall test is in the detection test. Recognition test. Recognition test, that is mainly the directions. Then they have a letter identification, picture identification on the behavioral pattern. In the resolution, they have a optokinetic preferential looking test basically. So these are the different variation tests available in the system. Okay. So commonly used method for the distance visual acuity is Sense chart, Landau-Broken ring, that is C chart, tumbling E chart, and Beliliobi-Logma chart. We have seen all three charts out of four. Since we have already the vision drum on second Landau, C we do not have, but we have tumbling E chart we have seen already over there. We have in our clinic, and Beliliobi-Logma chart, the 3-meter chart. We have already used it, all of you. There is the Beliliobi-Logma chart. These all three are there. So before going to start, talk about all the charts, how to prepare and all the measurement and all those things, I end this presentation over here. And next presentation or next talk, I'll talk about that topic. Okay, thank you.